Today I'm going to explain how to solve problem 10 from the general round of the HMMT of 2021. So, real numbers x, y, and z satisfy our first equation. X plus xy plus xyz is 1. Y plus yz plus xyz is 2. And z plus xz plus xyz is 4. The largest possible value of xyz is a plus b times the square root of c over d, where a, b, c, and d are integers, d is positive, c is square free, and the greatest common denominator of a, b, and d is 1. That basically means they have no factors in common. And we want to find 1000a plus 100b plus 10c plus d. So we need to actually find two of our substitutions. How we can do that? We can do that by first adding all these up. When we add all them up, so the first equation, x plus x times y plus xyz plus y plus yz plus xyz. And now we add the third one, plus z plus xz plus xyz. This is equal to 4 plus 2 plus 1, or 7. And now we see that all three of these equations have one similar term being added. That is xyz. We can factor out things from these first two terms, but not the xyz because we want them because they are all the same through the three equations. The first thing we're going to do for this one, the first one, is take out the x. So when you do that, it's 1 plus y, and yet you add the xyz, and then you do the same thing. You add the y, 1 plus z plus xyz. And then you take out the z, you get 1 plus x plus xyz is 7. Now we can add all the terms of x, y, and z and then subtract them from both sides to get rid of it from the left side. So we get x times 1 plus y plus y times 1 plus z times 1 plus x is equal to 7 minus 3xyz, 7 minus 3xyz. Since we added all the xyz's up and then subtracted them from both sides. Now we see how and where to do our substitutions. When we multiply all these three terms up, we have basically two factors being multiplied. The first substitution we're going to do is let's just say q be equal to 1 plus x times 1 plus y times 1 plus z. So basically what you did is you multiplied all these three together. The first thing you get is the parentheses being multiplied together. And our second one is we let p be equal to x, y, z. Since these are the terms in front of the parentheses. So we have our two substitutions, and adding all them up helped us find those two substitutions. Now, what we can do here is we can just multiply this out, find the value of q, find the greatest x, y, z, and eventually find our answer. Now, we see that this q value is still in a parentheses, so we can multiply it out and find a value. So q is equal to, once you multiply this out, you get a lot of terms, but all we want is these three terms the first two terms in all three equations. So we have them, which is x plus x times y plus y plus y times z, and then you add the last two terms, so z plus x times z. And then you have to add, and then you add a 1 and then add an xyz, but since we let p be equal to xyz, we just add a p. Alright, so now we basically have all of these terms for a q. What we can do here is, well, let's just like take a step back and look at what we have here. We have an xyz, well here, a 1, all these three terms. So what we can do here is we realize that these three parentheses, stuff inside the parentheses, well, they obviously intertwine with these three formulas or equations. Let's just take this first. So I'm just going to do this as an example. X plus xy is equal to 1 minus xyz, or 1 minus p, since p is xyz. So 1 minus p. You don't need the parentheses for this. So this is just 1 minus p plus, well, do the same thing here. 2 minus, no, you still need them. Just do that. Plus, plus 2 minus p plus 4 minus p. And then you still add the 1 and then add the p. Once all this has been dealt with and the dust settles, you'll be left with 8 minus 2p. So we now have a value for q that doesn't seem so big, or lengthy at least. Now what we do is we can multiply q and p together. So we multiply p and this value, which is q, so we multiply p by 8 minus 2p. And when you multiply these two together, basically what you have is you have x. So we want to separate these into the first two terms of all three formulas. Let's just take this x, for example. This is going to be brackets x times 1 plus y. And why 1 plus y, you ask? Because when you multiply this out, you get x plus xy, which is part of the formula up here. So we can keep on doing the same thing. It's not add, it's multiply. You just multiply this by y times 1 plus z here, and then you multiply this again by z times 1 plus x, right there. So now we have this formula that's going on right here. Now we can just multiply things out on the left hand side. We get 8 times p, 8p minus 2p squared is equal to, well, we can do the same thing we did earlier. Take this first bracket of, for example. This just gets x plus x times y, which is right up here in this formula. That's why we did that. So x plus x times y is 1 minus xyz, or 1 minus p. So 1 minus p. And now we can just follow through with the same logic. This is 2 minus p, and this is 4 minus p. All right. So now we just multiply this out. This is, well, that equals doesn't look so good. This is just equal to 8 minus 14p plus, 7p squared minus p cubed. And this is just still 8p minus 2p squared. Now we can move everything on the left-hand side to the right-hand side. I'm just going to put a comma here since I don't have space. 0 is equal to 8 minus 22p plus 9p squared, 9p squared minus p cubed. And now we realize we have a tiny bit of a problem. This is all negative. We want it positive. So what we do, just multiply both sides by -1. We still have 0. This is now equal to p cubed minus 9p squared plus 22p minus 8. So we have a new formula here, and we can factor it into possibly a few cases in which we solve for them, find the greatest one, and just simply find this. All we have to do is, right now, we have to find the roots of this cubic polynomial. We actually already have one of the roots. So recall from earlier that on the left-hand side, we have p times 8 minus 2p is equal to something. We don't care about the other stuff. We just care about this. This can be written as 2p times 4 minus p. So from here, we know that 4 is a root. And by whatever method necessary, or whatever method that works, we can take out that root. To get 0 is 4 minus p times p squared minus 5p plus 2. Now, we have two cases here. The first case, where 4 minus p is 0, where p is 4. Now, that can't be right, because it looks nothing like this. Even if it was like anything like that, we still have to check the other one to see if it's greater. So let's do that. So second case. So p squared minus 5p plus 2. When this is 0, we just simply use the quadratic equation to solve. P is equal to 5 plus or minus negative 5 squared, which is 25, minus 4 times 2 times 1, which is 25 minus 8, or square root 17, divided by 2. Well, this obviously looks like this, and basically works for all the constraints, and plus is probably larger than the other one. So what we have to do here is we want the larger value. So that's when it's 5 plus. Now, so this is 1 times the square root of 17. So we have all four numbers. A is 5, so 5,000 plus B is 1, so 100. C is 17, so plus 170. And D is 2. So 5,000 plus 100 plus 170 plus 2 will yield our answer, or 5,272. So we have solved this problem.